I'm going to walk through this problem. It's an example of finding a quadratic function that fits 3 data points. So a quadratic function is going to be some number times x squared plus some number times x plus c, just some constant number at the end. What we're going to do is plug in all 3 of these data points into this function, the x value for x and the y value here for f of x, and then we'll get 3 equations. So start with the first one. We're going to put a -4 in for the x and a -99 in for the f of x. So do that. There'll be one operation to do. You need to square when you put the x value here. You square it. So you get this for the function when you plug this point in. And do the same thing with the next 2 points. And you'll get that and your third equation. So we write them down here. We're going to go ahead and write the variable parts on the left and move the constants over to the right. So we line up our a's, our b's, and our c's, and we have a system of 3 equations. And you can use several methods to solve this. I'm going to use the elimination method, where I'm going to try to get rid of c. And if I get rid of c, then I would just have 2 variables, and there's methods, easier methods for solving when there's just 2 variables. So let's get rid of the c. If we look at our second equation here, it's got a positive c. If we multiply everything by a -1, so every single value on both sides, you get -25, a minus 5b minus c, and this is going to become a positive 225. And then the first equation I'm not going to change at all, because what I have now is a positive c and a negative c. So if I add those 2 equations together, the c's cancel out. And then carefully do all the other arithmetic. So a positive 16 and the -25 gives you a -9a. The -4 and the -5, add those together, you get a -9b. Here it's written as plus -9, but either way you write, that's fine. And then add these together as well. And it's a positive 225 and a -99 gives you 126. So there's one equation that just has a's and b's, and the c's are gone. We're going to do a similar thing to get rid of c again. We can't use equations 1 and 2, or else we'll get the same thing we already did. So I'm going to use the combination equation 1 and 3. You could also use 2 and 3 if you wanted, just as long as you don't use the same exact equations that you used up here. So I'm going to use 1 and 3. Again, just leave 1 completely alone and multiply everything in equation 3 by a -1. So equation 3, everything gets changed to the negative. And once again, just add those together. Add the a's, add the b's, c's cancel, add the constant. So now what you have is an equation here with just a and b, and an equation here with just a and b. What we want is to get rid of another letter now. We're going to use the elimination method one more time. This time when we do it, we'll be down with just a single variable, and we'll know what that variable is equal to. So using this equation and this equation, we need to cancel out either the a's or the b's. You can do either one. I'm going to cancel out the a's. So I need to find something that 9 and 12 both go into. I'll just use 9 times 12. So they both go into the number 108 because that's 9 times 12. So if I multiply this everything in this equation by a 12, I'll get minus 108a, minus 108b, and then 1512. And I need to change this to a 108. So multiply everything here by 9, and I'll get these values here. So now when I add those 2 equations together, the a's are gone. I'll add my b's together. Pay attention to the sign. Make sure you're adding those 2 negative values together, and add those values together. So now we're just left with b's. If we divide by that number on both sides, we'll have that b equals -6. And since we know what b is, we can plug that value in to either one of these equations because they just have an a and a b. these two equations we found, just an A and a B. So if we know what B is, we can plug that back in and we'll be able to solve for what A is. And then now that you know what A and B is, you can go back to any of these three equations. It does not matter which one you pick. Plug in the value for A, plug in the value for B, and all you'll have left is C to solve for. And that's how you would solve and find the quadratic function that fits 3 points.